Hi everyone, welcome to this course on DynamoDB data modeling. Now this is the introduction. You and me both know DynamoDB is the NoSQL offering from AWS. So when it comes to DynamoDB, the data modeling is much different from traditional relational data modeling that we are quite familiar with. Because of that, most of the newcomers to DynamoDB, they try to simulate the relational data modeling and finally ends up with huge AWS bills at the end of the month. So we should actually learn about best practices and recommendation of AWS DynamoDB before even trying to start designing our databases. So if you've done it correctly, DynamoDB will be quite cheap and it will give you millisecond latencies at any scale. So it could be 1 GB of data or it could be 10 terabytes of data. Amazing, right? So today I will walk you through a 5-step process that will help you in data modeling for your application. But before that, what really is data modeling? Now, data modeling is all about how an application stores its data in a given database related to the real world entities. Now there are two types of databases, relational databases and NoSQL databases. I assume you are already familiar with that, but let's take a quick refresher. Now relational databases have been in use for the longest time. Now MySQL, Oracle, Microsoft SQL Server are some of the examples for that, right? Relational databases use data normalization to split the data across multiple tables for efficient storage. Now, the storage is one of the main concerns. So, by splitting the data across multiple tables, you will eliminate any redundant copies of your data, thereby reduce the storage. So, why did you actually need to reduce the storage? Because the storage is quite costly back then. Although it is not the case today, those days it's quite costly. So that's why relational databases data modeling is mainly focused on optimizing the storage. Now, when we split the data across multiple tables, we have to join these tables in order to retrieve this data. So it needs more compute power when there are a lot of table joins to be done. And one other limitation in relational database is that the performance degrades as the database scales. So one of the reason is the complex queries that is generated by ORM tools can create a significant performance drain. Although it's not true for the small database environment, small application, when it comes to applications like social media applications which deals with big data, this really is a case. And also the relational databases typically has a strict schema. So you cannot have items with different number of attributes of different types in a single table because of this strict schema. In contrast to that, NoSQL databases are quite optimized for compute rather than storage. Because nowadays the storage is quite cheap, but compute is not. So you already understand what NoSQL databases are going to do. They are going to keep the duplicate copies of data and minimize the table joins so that it will reduce the compute power required to retrieve these data. And also, NoSQL databases provides flexible schemas. So the items with different number of attribute can be in the same table. And the main advantage of NoSQL databases is they scales quite well horizontally. I'm not going to go deep into horizontal scaling at this moment. So now that we know about NoSQL and SQL differences, let's talk about DynamoDB. You already know DynamoDB is the NoSQL offering from AWS. The main advantage of DynamoDB is that it provides consistent performance at any scale. DynamoDB guarantees millisecond latencies for DynamoDB operations. So if you design it well, you can have 10 to 20 milliseconds range of latency, and you can further reduce that into microsecond level if you attach caching on top of DynamoDB. For caching, of course, you can use DAX or DynamoDB Accelerator, and you can do it with minimum change to your DynamoDB queries. Now, there are some main points to remember or the best practices when data modeling with DynamoDB. As I've already mentioned earlier, you should forget about traditional relational data modeling. You should not fake the relational data modeling at all. Now, if there is one thing I really wanted to take from this presentation is this. You must identify almost all the access patterns for your application before designing your data model. This is very important. You should spend as much as time you need to identify almost all the design patterns. Of course, in reality, you might not be able to identify each and every access pattern, but try to identify most of the access patterns that will be used in your application. And once you have identified all these access patterns, you probably need just one table for your application. And Amazon also says in the documentations and all, you probably need just single table for the most applications. So we don't want to provision read capacity units and write capacity units for many tables and increase our DynamoDB bill, right? So once you have identified these access patterns for your application, the next major thing is to decide on the primary keys and indexes to satisfy your access patterns. So you identify the access patterns. Now you have to satisfy those access patterns. You should target to retrieve multitude of data in a single request. For example, if you are querying for a blog post, try to get the comments as well if required. Now I want to highlight this point again. Most applications only require just one table. This single table contains records for all your application entities. Example, let's say that you are modeling a software company. And let's say there are three entities, the company, projects, and employees. So the company data, projects data, and employee data has to be stored in the same table for efficient queries. So how do you ensure that the data can be efficiently retrieved? That is done by identifying the most suitable primary key which constitutes of hash and range keys. Now, if the primary key is insufficient to satisfy all these access patterns, then you should consider using secondary indexes. So I think you'll agree with me if I say there are a lot of things to consider before data modeling with DynamoDB. Because of that, I will show you 5 steps that will help you in modeling data with DynamoDB for your applications. Number 1, draw an entity diagram. This really helps you to identify the main entities for your application. So you can easily do the mapping between real-world entities and your application entities. Number 2, identify the relationship between these entities. With that, it will give you a lot of clues for data modeling. For example, if you see many-to-many relationship, you can think about inverted indexes. Number 3, list down all the access patterns for each entity. Now, this is the most important step of all. You should spend enough time at this step and identify almost all the access patterns required in your application. These could relate to CRUD operations, filters, etc. Number 4, identify the most suitable primary key, the hash key and the sort key for each of your entities. With proper hash and sort keys, you can satisfy most of the access patterns even without having any indexes. And number 5, identify the secondary indexes for additional access patterns if required. Sometimes your primary keys is not just enough to cater for all the access patterns. Then you should start thinking about local secondary indexes or LSIs and global secondary indexes or GSIs. Now let's put that into practice and come up with a data model for an example use case. Imagine that you are given a task to build a multi-tenant project management tool. Now this is a SaaS product, so any organization can sign up for an account online. So multiple organizations can create account in the tool. So you need to have multi-tenant support. And the main two objectives of this tool is to manage organization projects and assign employees within these projects. Now, in order to start data modeling for this application, let's start with step number 1. That is to draw an entity relationship diagram. Now, there are three main entities in our application. We have organization entity, projects, and employees. Let's look at the attributes for each entities. Now, for an organization, you have a unique organization ID, and then it has a name, and there's a tier that the organization belongs to. So this is basically, it could be the free tier or the professional or premium tier, something like that. So you choose a tier when signing up for this application. Then we have projects. There's a project ID to uniquely identify a particular project. There's a name and there's a type. Now there are two types of projects. There is agile projects and fixed bid projects. And the status of the project. And mainly we are updating status if the project is on hold. Then we have employees. For an employee, another unique ID, employee name, date of birth, and email. Now in the diagram, you can see the entity relationship is also shown. For an organization to projects, there's a one-to-many relationship. One organization can have multiple projects. Similarly, one organization can have multiple employees as well. So there's another one-to-many relationship between organization and employees. But between employees and projects, there's a many-to-many relationship because one employee can be part of many projects and one project can have many employees. So in the next step, we will further break down these relationships so we can further understand how to do data modeling for this type of a project. Step number 2, identify relationship. Now we have these three entities, organization, projects, and employees. Now I've broken down that many-to-many relationship into two one-to-many relationship by introducing another entity called project employees. So between employees and project employees, there's a one-to-many relationship. And between projects and project employees, again one-to-many relationship. Now even at this stage, we can identify that we need an inverted index to query one of the relationships. For example, to identify an employee's projects, we can use primary key relationships. But to query the other side of the many-to-many relationship or the employees that is part of projects, we have to use an inverted index. More on that later. Okay, now let's move on to the third step. That is identifying the access patterns. Now there are three main entities, including another sub-entity. So let's consider each of these entities and find out what are the access patterns. Now if we start with organization, first we should be able to do all the CRUD operation for an organization. We should be able to create an organization, read an organization, update an organization, and delete an organization. So that's a one access pattern. And then we should be able to find all the projects of an organization. Now remember, there's a one-to-many relationship between organization to projects. So we should be able to find all the projects belongs to an organization. Similarly, all the employees belongs to an organization. And apart from that, we should also be able to find all the projects and employees for a given organization. And there's another access patterns. This is about finding an organization by name, not by using the unique ID, the organization ID, but by using the name, just like a filter that we have to use in our front end. Now let's say these are the main access patterns that we have for an organization. Moving on to projects, there is again CRUD operations for a project, create, read, update and delete operation for one particular project. And then we'll have another front-end filter to be satisfied, that is about finding a project by name. We also have finding employees assigned to that particular project. And remember, there are two types of projects, agile and fixed bid. So we should be able to find all the agile projects as well as fixed bid project as well. Now the last one is about finding on hold projects. Now let's move on to employees. So similarly, we have CRUD operations for an employee, create, read, update and delete for an employee, and then finding all the projects that an employee is part of, because there's a many-to-many relationship between projects and employees, and we've broken down it to two one-to-many relationships. And finally, we should be able to find an employee by name, the front-end filter, okay? So we covered the three main entities, but there's another entity called project employee. So here, the main access pattern is about assigning an employee to a particular project. So step number 4 is about identifying the primary key for our table. So now that we have a good understanding about main access patterns, let's decide on what primary keys that we should use for identifying these entities. So we are going to have a single table for our application, and the primary key for that table is a composite of partition key and the sort key. The partition key is also known as the hash key, and the sort key is also known as the range key. So I assume you are familiar with DynamoDB hash or the partition key and sort or the range key. But just in case, hash or the partition key determines the correct partition that the data should be stored behind the scene. So to identify the partition of that particular data, DynamoDB used this value of the partition key. For example, let's say the partition key for an organization item is org hash 123. So it uses that value and take it and pass it to a hash function. And the result of that hash functions determines which partition the data should be stored or retrieved. So in this case, this organization item, where to put this item in which partition. So since it uses an hash function to determine this value, we call this key as the hash key or the partition key, since this determines the partition of that particular data item. Then we have sort key. Now this is about arranging the items within a partition. So DynamoDB uses this key to arrange items within a partition. And also we can use this sort key for multiple queries. We will see that in a bit. Now since we are using both partition key and the sort key as our primary key, the composition of these two keys has to be unique. So we have two main objectives when deciding this primary key or the hash and the sort key in this case. Number one, the primary key should be able to uniquely identify each entity within our single table, because otherwise we cannot use a single table to store all these entities. And number two is that we should be able to decide these primary keys for each entity, targeting to retrieve multitude of data using a single query. Now I hope you have noticed we have different prefixes. For example, here org hash, and then we have pro hash or project hash. So I've used different patterns for each entity. So what is the main reason for this? Because unlike relational database, when we query multiple tables and gather data and then share that data to the query that is received from the client and send it to client, in NoSQL database like DynamoDB, we store the data in the shape of the query so that we can use these string patterns to query multitude of data in a single request, thereby increase the query performance. So let's see examples in a bit. Now let's focus on organization entity. Now here the partition key is capital ORG hash, then whatever the organization ID. Then we have a sort key, starts with hash metadata hash. Now this is basically a placeholder, and then you have the organization ID. Now let's look at some example queries for organization. Now these are our access patterns that we have identified earlier. So in order to do the CRUD operation for an organization, create, read, update and delete, we should be able to uniquely identify an organization. For that, we can use our primary key and the sort key. Now look at this example. Now let's say there's an organization with the organization ID equals to 1234. So now we can use our primary key and the sort key to uniquely identify this organization ID. Now here's an example. pk equal capital ORG hash. Now this is the pattern, the prefix of the partition key. Can you see here? And then the organization ID 1234, and then sort key is equal to hash metadata. So this is the placeholder value, and then 1234. Since we have given exact value for both partition key and sort key, there is only one record in that table, because remember the partition key and the sort key, which is our primary key, is unique. So thereby we can identify this organization and perform all the CRUD operations. Now let's look at the other one. Find all projects of an organization. Now here we are expecting multiple projects. It's not a single item, right? So we are going to use the query operation here. And as the primary key for that query, we are going to use pk equal org hash 1234. And the sort key, we are going to use begins with operator. So I say, give me all the items that begins with pro hash belonging to this org hash 123 organization. Now similarly, we can use the next query to find the employees of an organization. So for both organization and projects, an organization and employees has one-to-many relationship. So here again I say my partition key is org hash 1234. this organization and give me items that begins with emp hash. So it will return only the employee records. Now if I want to get both employees and projects, then I should not even provide a value for the sort key. I'm just only giving my partition key org hash 1234. Then it will return both project items as well as employee items. So how about this access pattern? Finding the organization by its name. So using this partition key and the sort key, this is still not possible. Now let's move on to the example queries for projects. Now here's the project entity and the partition key for the project is org hash org id. And for the sort key, we use the prefix pro hash for project and then the type of the project, because if you can remember, we have queries to find a different type of projects as well, right? For that, we need this. And then finally, the project ID. Now, I want you to put your attention on the partition key selection for our entities. Now, let's go a couple of slides back. So for organization, projects, and employees, we have the same partition key, org hash org id. Now, this is because, guys, without an organization, these entities will not exist. You can't have a project without an organization. Even the employees belongs to an organization. So there is this hierarchy among the organization, projects, and employees. Organization is the parent and the project employees are its children. So all these queries run within an organization. So if you are doing a query against project or an employee, that is within an organization. So that's why we are using organization ID as our partition key for project and employees. Otherwise, your query will send results that belongs to other organizations as well. Okay, let's go back. Now we were here. So in order to do the CRUD operation for an employee, the primary key and sort key selection can be as follows. So let's say the organization ID is 1234 and the project ID is 100. So in order to uniquely identify a project, we have to give an exact value for primary key and the sort key. So the primary key value is org1234, matching this pattern, and the sort key value is pro hash, then the type, let's say this is a agile type project, and then the project ID 100. This will return a single item, then you can perform CRUD operation on top of that. We still can't find a project by name, and we still can't find the on-hold projects. Let's take a couple other examples. Now look at this. Find agile projects. So here we are expecting set of projects to be returned. So the primary key is org hash 1234, and then we are using again the begins with operator. Sort key begins with pro hash agile. So we are giving values only for the first part of this pattern, pro hash, then the type is agile. We are not specifying the project ID, so thereby we use the begins with operator and it will return all the items that belongs to 1234 organization and the sort key begins with pro hash agile. Similarly, to identify all the fixed bid projects, we use begins with operator again with pro hash the type equals to fixed bid. I hope you understand. Okay, let's quickly move on to employees as well. So we can do the CRUD operations in the similar manner, but still we cannot find all the projects that an employee is part of. And also we cannot find the projects by name. So now let's move on to step number 5 in order to satisfy these other access patterns. So step number 5, identifying the secondary indexes. Yes, we are going to use secondary indexes to identify those other access patterns. Now, this access pattern is one of the not satisfied access pattern. That is finding all projects an employee is part of. Now, if you can remember, I told you we have to use an inverted index to query the other part of the many-to-many relationship. One side of the many-to-many relationship can be done using the primary key, but to query the other side of the many-to-many relationship, we have to use an inverted index. Now there are two tables. This is one of our table entities, project employees. So it is this one. So I isolated only that one here. And there the partition key is like this. Then org hash, then the org ID, because we always need to filter by the organization ID. And then we have another prefix, hash project or hash pro, then the project ID. So this is the partition key, and the sort key is the org hash org ID, And here is the employee EMP and the EMP ID. Now, if I want to get all the employees belongs to a project, so what I can easily do is I can send an query where its partition key is equal to org hash, then the org ID, let's say 1234, then hash pro hash, then the project ID, let's say 100. And I don't have to specify any sort keys, thereby it will return all the employee items that is related to this particular project. So with this primary key, we can query one part of the many-to-many relationship. Here, finding all the employees belongs to a project. But how about finding all the projects and employees part of? So in order to make that query, what we need is to switch this ID in the sort key to the partition key and the partition key value to the sort key. So we need to invert this. So for that, we are going to create a GSI or a global secondary index. We'll call it project employee index. And as the primary key for that GSI, we are using the sort key value of our table. So it is organization ID, then the EMP value, you see. And for the sort key, we are using the primary key. Now we can again easily query this GSI to find the projects and employees part of. Here's an example. Primary key is org hash 1234. Then let's say there's an employee with employee ID 300, hash EMP hash 300. We are not giving any sort key values, thereby it will return all the items that this employee is part of. Okay, now let's look at another example. Now this is about finding all organizations, projects and employees by name. Now this is another access pattern that we couldn't satisfy so far. And I told you earlier, in our front end, we have a filter to filter projects, employees, and organization by its name. Now for that, we are going to use GSI overloading. Now when we define a GSI or a global secondary index on a table, we can use different attributes as the partition key and the sort keys of that GSI, which are different to the partition key and the sort key of the table. So now look at this example. Now here, as the partition key of our GSI, I'm using the partition key of the table itself. But for the sort key, I'm not going to use that SK attribute. Instead, I'm going to use another attribute called filter name. Now this is a different attribute. So when I'm inserting organization, employee and project records or items into this table, I'm using this prefix for this attribute specifically. For example, say that I'm adding an organization. So my primary key is org slash then organization ID. And for this filter name, I use this prefix org hash then the organization name. So if I'm adding an employee record, then the partition key is org hash org ID. And for the filter name, I add emp hash emp name or employee name. Similarly, for projects, project has project name. So now we can issue queries on our GSI like this. Now if I want to find an organization by its name, so what I can say is I'm querying my GSI where its prime partition key is equal to org hash 1234. Here it matches here. Then the filter name attribute equals to org hash happy inc. Let's say the organization name is happy inc. So I don't necessarily have to use the organization ID here, instead the organization name. Similarly, if I want to find an employee by its name, then the partition key is org hash 1234 and then the filter name equal to emp hash, let's say I'm searching for the employee called Manoj, then Manoj. So I don't have to use the employee ID here. Now we can satisfy this access pattern as well. Now guys, if you have a lot of text queries like this, finding by name, age, and so many text queries, then there's a better approach. So here we are basically using an Elasticsearch cluster. So what we'll do is we'll enable DynamoDB streams so that anytime we insert a record, delete or update a record, the DynamoDB will trigger a stream and I will use a Lambda function to intercept that stream data, identify the operation, whether it's create, delete, update, and then index that data item in Elasticsearch cluster or Elasticsearch service. Then if I want to do a lot of text searches, I will query the Elasticsearch service instead of my DynamoDB because Elasticsearch is made to do advanced text searches. It uses Lucene indexing to do lightning fast queries. So I will do all my CRUD operation like creating records, updating and those things directly to the DynamoDB. But if I want to do filters queries like text-based queries, I will use Elasticsearch directly. Okay, let's move on. Now we have another access pattern that we couldn't satisfy yet. So that is about finding on-hold projects. Now imagine that an organization has 100 projects. And out of that 100 projects, let's say 3 projects became on hold. It could be due to some budgetary restrictions or whatever. So how do we query for these on-hold projects? Now one option is obviously we can define an LSI or local secondary indexes on this particular attribute called is on hold. So that's a one way. But here I want to introduce another way of doing that or a pattern that used in DynamoDB. So that is called sparse indexing. So sparse indexing is nothing but another GSI or global secondary index, and we select is on hold attribute as its partition key. Now those 3 projects are on hold out of those 100 projects, right? So what we're going to do is we will update this is on hold attribute to true or any other value for that matter in those 3 on hold projects. So global secondary indexes behind the scene it will maintain a separate table with the indexed items. Now since we have updated is on hold attribute for only those 3 projects, only 3 items will be written to that index table. It's not going to write all other 97 attributes or items in that index table. So that is called sparse indexing. So GSIs are in general they are sparse indexing. So what we can do next is we can then either use query or scan on this GSI. Now we can use either scan or query both because in that particular index table it will contain all the records about on-hold projects. It doesn't contain anything else. Okay, now we have gone through all our 5 steps. Now if you have some experience in DynamoDB, you might have remembered there's another thing called filter condition. Now filter conditions are used if you want to further filter results by non-key attributes. Now the important thing to understand about filter expression is that this is applied after query finishes. Now let's take the same example that we discussed in sparse indexing. Now we are not defining any GSI on is on hold attribute. Instead, you are going to use a filter condition. So in the query you say filter by on hold is true. So you add a filter expression is on hold equal true and expecting those 3 results. Of course you will get those 3 items, but the thing is before it does that final filtering, it will query all that 100 records in the table. So you have to pay for read capacity units to read all that 100 records. So that's why it says in the documentation, the query consumes the same amount of read capacity regardless whether a filter expression is present. So we have to be careful when to use filter condition. So one of the common patterns is we do all the filtering based on our partition key and the sort key, and the result that is returned we apply filter condition. So that is all right. And there's another use case for using filter condition. If the secondary indexes costs more than the filter condition, so that could be due to the low query velocity or the frequency, then you can again use the filter condition. Now here the reason is if you define a GSI, then you have to allocate capacity RCU and WCU for that GSI, right? And if that GSI is not frequently used, then you are spending money on that. So you have to check the velocity and the frequency of the queries against that GSI. If it is very low, then you can check the cost comparisons and maybe the filter condition will give you better cost implications. Okay, now this is the content that I wanted to cover. So in the next episode, let's implement this example using DynamoDB Node.js SDK. Now let's implement our example use case of our online project management tool. So we identified 3 main entities. organization, project, employees and project employees. And also we will identify the partition key and the sort key for each entity as well. So let's go to AWS console and select the region US East 1 and create a DynamoDB table. So let's name the table Happy Projects, given that this is a project management tool. And I select the partition key as pk of string type, and also I will add a sort key sk of string type as well. So I'm going to use provision capacity here. I'm not going to use auto scaling. So I will just provision one RCU and one WCU, and then I will create the table. So now open up Visual Studio Code in an empty directory and create a file called index.js. And let's initialize a Node.js project by npm init. And we are going to use JavaScript SDK. So in order to communicate with DynamoDB, thereby we need to have AWS SDK installed. So I'm installing AWS SDK together with DJS for date manipulation. And also I will add GUID or UUID for unique ID generations as well. So once it is saved, I will create a constant AWS by requiring AWS SDK. Then let's set the AWS region to US East 1 or North Virginia. So you can find the AWS region from AWS console, and there's a region code on the address bar as well. So I also require GUID up here, so I will assign it to another constant. And then let's create a DynamoDB instance to communicate with DynamoDB. So const DynamoDB. And we are going to use DynamoDB document client, which is a much simplified client to interact with DynamoDB here. Okay, so now let's go about creating an organization. So what is the partition key and the sort key in order to identify an organization uniquely? So let's go back to our slides and find that out. So for an organization, the partition key is org hash org ID, and the sort key is hash metadata hash org ID. We discussed this the other lesson. Okay, now let's look at DynamoDB SDK documentation. You can just simply Google it and click the first link appearing. Now this is the documentation for AWS DynamoDB. However, we are using a much simplified wrapper library of DynamoDB, which is called document client. You can find it right here. So click on that. Now these are the methods supported by DynamoDB document client. We are going to use put method. So this put method allows us to create or replace an item in DynamoDB table. So I'll click the link and copy the example code. Now let's go back to our editor and paste that in. And now we need to edit the attributes. For example, the table name should be happy projects like this. And the hash key or the partition key, so it is pk, and the value is also, we can find it from the slides, org hash org ID. Now before that we need to have an org ID. So let's use our GUID library to generate an org ID. So this is a unique ID, and I will type org hash, then append that org ID. Okay, now I'll remove the rest of the attributes. What I need is another attribute, our sort key or the range key, which is of type or the format hash metadata and the org ID. So let me add that as well, metadata hash and org ID. I will also add the name as another attribute. Let's call it Happy Inc. for this company name, and we can add other attributes if you will. And then I will pass this params object to DynamoDB put operation, and then I will console log the output here. Now there's an important step which is not shown here. So in order to communicate with AWS services from the local machine, you have to install AWS CLI and configure it with your IAM user credentials. So I'll post a link below, and once it is completed, let's run our application by node index.js, and if it is successful, we should return an empty object. So let's check that in DynamoDB console, and there we go. We have created our very first record of organization type. If I open up the item, you can see the name, PK, SK, and all the tier information that we added. And now let's create another organization with other information. For example, let's call it ABC Incorporation here with the tier of professional. So I will execute it using node index.js. Again, I should return an empty object. Refresh that. There you go. So now I have two organizations. So let's add projects to this organization. So this is the query that I'm going to use with the partition key and the sort key. So let's create a project in Happy Inc. first. I will copy the code from the earlier query. So I have to use org hash org ID, and for that I need to find out the org ID of Happy Inc. So let's go to that record, and here we have the org ID after hash. Let me copy that and cancel this out. So let's have it in a constant. I will call it Happy Inc. org ID and just paste that value. And I need to have a project ID as well. So we'll get to that in a bit. Here I will change the org and the org ID to Happy Inc. So partition key is fine. Now the sort key, it has to be starting from pro hash, then the type of the project, and we'll call it, this is an agile project. So it is agile, and then the project ID. So we'll get another unique ID for project ID. I'll use our GUID library. So get that project ID and put it there. And let's call it the project name as project X. And I will separately have the project ID in a separate attribute. And afterwards, I will execute this query with node index.js again. If I refresh it, now I should see three items. So there we have our project X record. Now, I always want to go to my organization record and then copy the organization ID. So instead, I need to create another attribute called organization ID separately. So let's edit that organization record. For that, I will use update. So here, I will have the Happy Inc. organization ID, and the table name is again Happy Inc. and the hash key is PK, and its value of the type of org hash org ID. I will replace org ID with my Happy Inc. org ID. Now we have to say what sort key is. So remember, we need both of these keys to identify and record uniquely. So here also it's Happy Inc. org ID. And then as our update expression, we need to add a new attribute. So we'll call it set hash org ID to the value. We will use another placeholder here, colon org ID. Now I can give the names for this placeholder. The attribute name placeholder hash org ID is org ID, and the attribute value, the placeholder was colon org ID. And for that, I will use Happy Inc. org ID here. So now I will have a separate attribute called org ID, so I can easily copy from my table. So now let's execute it. Node index.js. Now if I refresh it, I should see a new attribute for my organization. There we go, org ID and the organization ID. So now I don't have to go into the record and copy that part after hash. So I will copy the org ID for ABC as well. So let's create another org ID attribute for ABC organization as well. So it's the same thing, but just the difference is the ABC org ID. So let me replace ABC org ID here and then execute it so that we will have another attribute org ID for ABC as well. So two org IDs here. So let me create a couple other projects for query. So now I have two agile projects. So let's create some fixed bit projects as well. So I will assign these projects into ABC company as well. So now I have a set of projects assigned to both of these companies. Now it's time to do the queries or access patterns. So the first query is to find an organization. So the method that I'm going to use is the get method. Now you can easily copy this example code and change the parameters right here. So the table name is happy projects and the partition key is in the format of org hash org ID. So I'll copy the org ID from the attribute that we updated earlier. And we have to define sort key as well in order to uniquely identify this particular organization, the Happy Inc. So the sort key is in the format of hash metadata and then the organization ID. Now I think we are good to run this query. So let's run this and see if we get the information of Happy Inc. So there you go, it returned the Happy Inc. organization data. Now let's run another query. So this is about finding all the projects assigned to the organization. So we'll use the same Happy Inc. and try to find all the organization or all the projects assigned to this organization. So this time I am expecting more results. So in this case, I'm using the query method. Earlier we used get, so because we are expecting just single result, but this time it's a query. So in the query, we have to define the table name as usual. So we are not querying any index, so take this out. And then we have to specify the condition expression. So this is about finding all the projects of Happy Inc., right? So since the projects belongs to a particular organization, the partition key is org hash, whatever the organization ID, in this case Happy Inc. And then sort key, we are using begins with operator because in this partition we have projects, employees, and project employee record. So we just want to filter only the projects. So we are going to use begins with operator. We have multiple operators like this, begins with, in between, ends with, like that. So for this query, we use begins with the prefix of project, which is pro hash. So I'm going to use expression attribute names to provide values to these expression attributes. So pk is pk and hash sk is sk because we have common names of p partition key and sort key. So it's time to provide the values for these attributes. So pk in the forms of org hash org id. So org hash, then the happy inc id. Then the sk is just pro hash. So this is the prefix of project. Now let's run this query and check whether it works. Beautiful. So it returned project X, project Y, and project F1 of Happy Inc. So it returned all the fixed bid and agile projects of Happy Inc. So in this video, we are going to cover the additional access patterns for our DynamoDB data modeling application. We are going to cover the inverted index. In the upcoming video, we will cover the GSI overloading and sparse indexing. So what is an inverted index? Inverted index are used to model a many-to-many relationship. Now, one part of the many-to-many relationship can be queried by the table primary keys using the partition key and the sort key or the primary key of the table. But when it comes to other part of the many-to-many relationship, the other side of the many-to-many relationship, we can use an inverted index to query that. Now let me give you an example. So this is the example use case that we have been discussing over. So in this example, it's a project management tool and it had projects and employees, these two entities. So between these two entities, there's a many-to-many relationship. One project can have multiple employees and one employee can be part of many projects. In a previous lesson, I broke this many-to-many relationship into a two one-to-many relationship using a third additional table. So I called it project employee. So there's one-to-many relationship with employee and projects, and projects to project employees, there's another one-to-many relationship. And after that, we've identified the partition key and the sort key for project employee entity. Now, look at this top table. I've isolated only the project employee entity here. Well, it had project employees and organization entities as well, but here I isolated only the project employee entity. Now this project employee entity, it has a partition key of org hash, org ID, then pro hash, the project ID. We use this org hash, org ID to denote our hierarchy because all the project's employees are part of an organization, so it has to be within an organization. So that's why this org hash, org ID. So similarly, for the sort key, we have a similar format. So org hash, org ID, it's the same, but instead of project or PRO, we have EMP and then the EMP ID or the employee ID. Now using this table primary key or the partition key and the sort key, I can easily query for the employees list of a particular project. So I can query one part of the many-to-many relationship. So all I have to provide is the PK value or the partition key value here. So org hash, then whatever the org ID, then hash pro hash, then whatever the project ID. Then it will return all the employees or the records inside this partition. So I don't necessarily have to enter a value for the sort key. This can be left blank or empty. But when it comes to querying the other way around, like to find out the projects that an employee belongs to, then I can use a similar pattern. But unfortunately, I cannot leave the partition key empty. So that's why I need to define a new GSI. So in this case, I call project employee index, where its primary key is the sort key of the table. See, so this is the sort key of the table, but that becomes the primary key or the partition key rather of the GSI. And the partition key of the table becomes the sort key of the GSI. So because of this inverse selection, we call this an inverted index. Now let's look at an example. Alright, right now I am in the DynamoDB table and I have two organizations, Happy Inc. and ABC Incorporation that we created in the previous lessons. And under Happy Inc., we have Project X, Y, and F1. Project X and Project Y are agile projects, and F1 is a fixed bid project. Now let's create some employees and assign them into these projects. So here's I'm back in the code, and let me uncomment the first block of code. So here I create a employee called Manoj in Happy Inc. So I have the Happy Inc. organization ID and I'm generating an unique ID for Manoj. So as parameters, we have to pass the project or the table name Happy Projects, and we need to specify the partition key and the sort key for creating an employee entity in our database. So during an earlier lesson, we discussed the partition key for an employee is in the format of org hash org ID, just like this. And the sort key of an employee is of EMP hash employee ID. We can provide other information like employee name, email, and so on. So I give employee name and email, then we will run DynamoDB put operation in order to create the record in DynamoDB. So let's save the changes. I'll take a terminal and I run node index.js. So it's successfully executed. Now if we refresh the table, I should see Manoj Fernando created inside our table. So let's create couple other guys. I will say John, and I also create Jane as well. Now let's assign Manoj to both project X and project Y because Manoj can be part of both projects. I will uncomment this block of code. So this is about assigning an employee to a project. So this is the Happy Inc. project ID. This is project X ID, project Y ID, and project F ID. So we are focusing on project X for Manoj. So let's pick the ID for Manoj, employee ID. So if I go to Manoj record right here, and the employee ID is right here after EMP hash. So let me copy this. Here we use the partition key and the sort key of employee project entity. So if you can remember, it has org hash, then the org ID, then hash project, then project ID. For the sort key, it is pretty much the same except instead of project PRO, this is an EMP for employee. Then I've added the employee ID. I can add some any additional information like I can have the name of the employee like Manoj and the project text as metadata and also another metadata for date of join. So let's execute that. If I refresh the table, I should find project employee entity record. Here we have it. So date of join, name, and the partition key and the sort key and the project. Great. So let's add Manoj to project Y as well. So instead of project X here, I will specify project Y. And let's execute the same command. So he's assigned to both of these projects. Now let's get the ID of John and add him only to project X. So I get the ID of John right here after EMP hash. And in the same time, I'll get the ID of Jane as well. Okay, so now let's assign John to project X. I will select John. Now I add Jane to project Y. So instead of John, this is Jane. Instead of project X, this is project Y. Okay, so now that we have assigned employees to projects, so let's see how to query the employees assigned to a particular project. So let me comment out this code. So this is about finding employees assigned to, in this case, project X. So I have Happy Inc. ID and also the project X ID. So these are the parameters I'm passing down to DynamoDB query, table name Happy Inc. and the key condition expression partition key hash pk equal the pk value. So what is the pk value? So it is nothing but the partition key of our project employee entity, which is org hash, then org ID, hash project or pro hash, then the project ID. So we don't have to specify sort key. This will query one part of our many-to-many relationship between projects and employee. So let's run this and check if we get all the employees assigned to project X. Great. So I got both John and Manoj who are assigned to project X. But hey, how do we find the projects that Manoj is part of? Well, for that, we have to use that inverted index. So let's create an inverted index. I go to the indexes tab here. Now I already created this index. So for the partition key, I selected the sort key of the table. For the sort key, I selected the partition key of the table. So how can we do it from scratch? Click create index here, and then you are supposed to type the partition key. So in this case, you have to type the sort key of the table sk and check add sort key. And here for the sort key, type pk. So it is the inverse. And you can provide any name for the index, which we are going to refer as the index name when querying. So I'm going to project all the attributes, or you can pick keys only, or you can include certain attributes. So in this case, let's pick all for this demo. And you have to specifically mention what is the RCU and WCU for this index. Since this is a GSI, we have to specify these RCU and WCU units. And then click create index. So I will cancel this out since I already have it. So now let's query this index in order to get the projects that Manoj is part of. So I will comment out the previous code block and then uncomment the last code block here. So we need the ID of Manoj, which I can copy from here. And this is the organization ID. Now these are the parameters that we pass down to our DynamoDB query. As usual, we have to specify what project this is. This is happy project. Now in addition to the table name, we have to specify the index name as well. So our index name is project employee index, which is this name. And then as the key condition, we use the sk attribute because sk attribute is the partition key of this index. So I can only pass value to sk. I don't need to specify any value to pk. So what is the value of sk? So I can easily say org hash, then the org ID, and then it is emp hash, the employee ID, which is Manoj. Now this should return all the projects that Manoj is part of. Now this is the other side of the many-to-many relationship between projects and employees. So let's run this. So Manoj is part of project X, and also Manoj is part of project, well, this should be Y. I think I did not type the project Y name when I was assigning Manoj to project Y. Instead, I copy pasted it, so I forgot to name the project name. But here you can see the difference. You see, this project ID is one thing, start with EB, and this project ID start with 25. So these are two separate projects. So that's how you model many-to-many relationships using inverted index. So today we are going to talk about GSI overloading. Now, DynamoDB table doesn't need to have a strict schema. Now, unlike in relational databases where the schema has to be uniform and strict, a DynamoDB table can have different data items. For example, projects, employees, organization in the same table. And the number of attributes in these data items can also be different. And in fact, the same attribute in two different data items can have entirely different value. They don't have to be exact same. So in GSI overloading, we exploit this ability to have different types of data for a particular data attribute in order to minimize the number of GSIs required for a table in order to query different access patterns. Now let me explain it a little bit more. Now in general, we have common attributes names like data in a DynamoDB table. Now even though the attribute name is the same, like data, the value of this data attribute can be different. Now have a look at this example. Now this is from the DynamoDB documentation. Now you see the first data item is about employee name. Now in this employee name, the data attribute represents the name of the employee, Murphy John. Whereas in the second data item, the value of the data attribute represents the order totals in USDs. So it's entirely different. And in the third data item, it represents a date. So you get the idea, right? So in GSI overloading, what we'll do is we'll create a GSI or global secondary index and designate this data attribute name as the sort key of the GSI. And in fact, we will add prefixes in front of these data values as well. For example, here it's Murphy John, which is an employee name. So the prefix could be EMP hash, or it could be anything. Maybe for the date, the prefix could be date hash. Now, once we have prefixed these data values, we can query this index with DynamoDB operators like begins with, between, etc. So we can say begins with EMP hash. So it will return all the data items where the entity type is employee name. So we call this GSI overloading. So in GSI overloading, it reduces the cost by reducing the number of GSIs required for the table. So here again it says now the data attribute represents different types of data. We discussed this already. Now, when we look at our project management tool that we have been discussing so far, it has these three types of entities: organization, projects, and employees. Now, there was a requirement for front-end filters. We already discussed this. A quick recap: we need a requirement to get all the organizations by its name. And also from the front end, we should be able to get all the projects by the project name. And similarly, we should be able to get all the employees by their name, because whoever using the web front end can easily type the names rather than remembering the IDs of the organizations, projects, or employees. So how can we go about implementing these filters? So as you have already assumed, we are going to use GSI overloading. So the first step is to create a common attribute. So in this case, let's call it data. So this could be anything. So I have a new attribute called data. And in this data attribute, we are going to prefix some constants value to identify each entity. Here for an organization entity, we prefix it with org hash. Then the rest of it is the organization name. For project, the prefix part is pro hash, then the project name. And similarly for employees, it is EMP hash, then the employee name. So when we are inserting records into this table, let's say we are going to insert a new organization, for the data attributes, we will just simply add org hash, then whatever the organization name. So similarly, we do it for projects and employee records as well. So once we have data like that, we can simply create a new GSI. So the GSI name, for example, filter by name. And for this GSI, we can define the partition key as the partition key of the table itself. So it can be the same. But the sort key, we will point it to the new data attribute. Now you might have a question like, since we are using the same partition key of the table, should that be a GSI or can't that be a LSI or a local secondary index? Of course, it can be a local secondary index, but LSI has this, storage limitation, so it's safe to use GSI. So now how can we satisfy our queries? If I want to find an organization by its name, so what I can easily do is I can easily query the GSI, filter by name GSI, where its partition key is org hash, then whatever that organization ID, and its sort key. In this case, it's data. We can pass the constant prefix org hash, then whatever that the user picks or types into the front end. So in this case, let's say happy ink. Hey guys, so I'm on my AWS console. So I will go to DynamoDB. I will select table from the left sidebar, and this happy project is the table that we created earlier. So in this happy project, we have the partition key as PK and sort key as SK at the moment. So let's go into the table and I will view the existing items. So at the moment I have set of employees assigned to a particular organization and I have 3 projects as well. So step 1, we will add a new attribute called data. And the value, now this is an employee entity, the John Doe. So the prefix should be ENP hash. and then John Doe, employee name John Doe. Now we'll edit another employee. Now when we're creating a new employee, we can of course add this data attribute at creation time as well. I will save this employee as well and we'll edit the final employee. So I will edit a couple of projects as well. Now this is one of the projects. Let me click onto that. So it's project X belonging to the same organization. So what I will do is I will click append and string. So the attribute name still the data, but the values start with PRO because it's a project and then the project name, project X. Save it. Let's edit the second project. So let's see how can we query this using a GSI. Now before querying, we need to have a GSI. So what I will do is I will click indexes here and then I will create a new index. Click create new index. The partition key, as you remember, it is the table partition key itself. So that is PK. And I'm going to add a new sort key. So this time it is not the table sort key, which is SK, but the data attribute that we created. So I will type data and this is of string type. I can change the filter name, filter by name, and I'm setting the RCU and WCU to the exact values that I set to the table, which is 1. That should be enough. I will click create index. So while it is creating, I go to the text editor and this is the editor that we've been using so far. It is Visual Studio Code. And here I am requiring the AWS JavaScript SDK and I'm configuring my SDK with the region that I am right now in, US East 1, and I'm using the document client. So I need to now query the GSI, not the table. So the parameters that I require is, of course, I need to have the table name, which is happy projects. Then the index name, so it should be filter by name, which we just created. And then the condition expression. So the condition expression looks like this. So I'm using expression attribute names, hash pk, and the value of pk. So I will use the begins with. So as the first query, I'm going to find an employee by its name. So for the condition expression, and here I'm using expression attribute name. I will tell you why I'm using like that in a bit. So it is hash pk, then this is the expression attribute value, colon pk, and I'm using the begins with operator. So the hash pk, it is the partition key which we are using the table partition key itself, which is pk. And for hash sk, which is the range or sort key, it's not sk but the new attributes data here. Now the reason we had to use expression attributes name is that this data is a reserved keyword. So you can't simply replace data here. That means gonna give you an error. So what are the values? So the partition key values. So I'm using the table partition key format, which is org hash, then the org ID. And for the value of the data, it has to be emp hash, which is the prefix of the employee. And I will just search Manoj. And you can remember the full name is Manoj Fernando. But let's try to search for Manoj and see if we get Manoj Fernando there. And I'm executing the query here. Now the index is created properly. So I will take an terminal and I will run this query node index.js, hit enter. There we go. I get this record Manoj Fernando. Now if I search for John, John, and run the query again, I will get John Doe. How about if I just add only J here? Let's see. I will run it again. There we go. I get both John Doe and Jane Doe. Now let's query for projects as well. So the only thing that we have to change is the prefix. So instead of EMP, it has to be PRO. And let's type project, clear the screen, and then I will run this query. So I get both project X and project Y. If I only search for project X, then it should only return project X for me. So this is the end of demo. So I think it's a very simple demo on how to use GSI overloading. Thank you very much for watching, guys. I'll see you in a new video.